have by now some familiarity with the toolkit functions, and presumably everybody knows how to quickly make a table using standard values, construct a graph quickly within a minute or so of any of the toolkit functions, at least any of the three most basic, and hopefully the five, and hopefully even more than that. Okay, but anyhow, as you know, many of the toolkit functions can be constructed inside a rectangular box, 4 units on a side. Now, a couple of them, you want to do 4 units here and 8 units here. And sometimes that box or rectangle is symmetric with respect to the x-axis. In other words, the x-axis goes right through the center of it, and sometimes not. Now, the basic squaring function and basic reciprocal function, the toolkit squaring function, toolkit reciprocal function would fit into this box. If we move the box, so let's just say we have, well, let's just talk about moving the box. Okay, so here's a box. Let's go ahead and make the box. Would make the borders of the box perfect. Let's say that we want to move the box so that it lies here. Okay. This point here corresponds to which point on the purple box? Okay. This lower left-hand corner of the green box corresponds to what coordinate on the purple box? Think that through before you see me answer. You should be able to answer that question very easily. And clearly, the lower left-hand corner of this box is going to correspond to the lower left-hand corner of this box. Now, how far did the lower left-hand corner of this box have to move in order to get here, and how far did it have to move in the vertical direction? So obviously, I had to take this box. I can describe the displacement of this box by saying I moved the box over a ways and up a ways. How far did I have to move it over, and how far did I have to move it up? Specifically for this point, how far did it move over, and how far did it move up? Well, again, you should think that through. But this corner is -2, 0. And this corner on the green box is .22. Okay, well, a couple of things. It should be obvious. The box has a width of 4. If this box is moved over to here, I had to move it 4 units to get here and 2 units up, right? Okay, so we moved four units horizontally and 2 units vertically. And every point of this box moves over 4 units and up 2 units. So that take the coordinates of this point, which are -2, 4, and you should be very familiar with that by now. Okay, so we move it over 4 units horizontally. We start at horizontal coordinate or x coordinate -2 and move it 4 units. We're going to end up at x equals +2. So the x coordinate will be 2. And the y coordinate is going to have to move up 2 units. And that's going to put it at the point 2, 6. Okay, so every point. I won't list all the other points, but I could well ask that of a quiz. Every point is moved 4 units in the horizontal direction. And 2 units vertically. There we have it. If inside of this box, we constructed one of our toolkit functions, for example, the toolkit squaring function, then here's the approximate graph of that function. And I'm going to sketch my axis of symmetry to keep myself fairly honest. And every point of this graph will have been moved 4 units this way and 2 units this way. So just to take a random point of this graph, let's take this one here. And if we move this point up 2 units, it's going to go, well, 2 units is about this far. So there's an arrow representing 2 units. And over 4 units, I get the corresponding points on this graph. And if the graphs are drawn accurately and the arrows are drawn accurately, we have a +2 vertical and a +4 horizontal. Now, this point will lie on the curve in exactly the same position. This point lies on its curve. Okay, now I'm going to ask you, take this picture here, draw it as best you can. My rectangle probably should have been a little higher to have the same height that it does width, but whatever. Dimensions of the rectangle are 4 by 4. So maybe my vertical scale isn't exactly the same as my horizontal scale. This thing isn't totally symmetric. Should have been a little further on this side or a little shorter on this side, but still. So draw your best picture. And then we're going to do 4 moves. Okay, the first move, we're going to move the rectangle 1 unit horizontally and 3 units vertically. So I'm going to ask you to do that. And you should pause and actually do this. And hopefully you pause. Now, if I move it 1 unit horizontally, well, that's going to move. Let's just pick a point. We'll pick a convenient point. We'll take this point here. And we'll move it 1 unit horizontally. So now it's here. And so this side is going to go here. And it's going to move 3 units vertically. Okay, well, it's going to have to move up 3 units vertically. This is 4 units here. So 3 units in the vertical direction would be here. So it's over 1 and up 3. And that's going to be the lower right-hand corner of the box. Now, every other point is going to move similarly. So I'm actually going to go ahead and sketch this. This point's going to move to here. This point is going to move here. And this point will move to here. So now I've got 4 points. And the graph is going to look like this. Okay, so this is number 1. Okay, so now see if you can do number 2, and number 3, and number 4. Again, hopefully you've done that. At least you've done what you can do. Okay, if I move this original rectangle, and let's go ahead and sketch the original rectangle in purple. If I move this -2 units in the horizontal direction, then this point is going to move to here. And this point is going to move over here. Well, horizontal. This point will move over to here, and then it'll move 2 units down. Okay. Horizontally, 2 units, vertically 2 units. So we're going to have a point here. This point will move horizontally 2 units, and 2 units is about this far. So this point's going to move over here and then down 2 units. And now the lower edge of the rectangle is going to go here. And what about the upper edge? Well, if I move this over 2 units and down 2, remember it's 4 units high here, so it's going to come down to here. Okay. And then if we move this point over 2 units and down 2 units, it's going to end up here. It's going to look like this. Okay, so this will be number 2. Number 3, we move over 3 units and up 5. So if I take this point and move over 3 units, so this would be 1 unit, so 3 units and put it about here. This point will go to here. This point would go over 3 units. Now 2 units gets into the origin, 1 more unit gets in here. So here's our lower edge. Oh, never mind. I didn't move it up 5 units, did I? So I got ahead of myself. I'm going to ignore that line. Okay, well, again, this goes over 3, then it has to go up 5. Now, height here is 4, so 5 is going to be a little higher than that. So I'm going to go about here. And this one's going to go about here. This will be our lower edge. I'm sorry for my error there. Okay. Then the upper corners, but each of the upper corners is 4 units higher than the lower corresponding lower corner. So I'm going to have to move up 4 units here. And up 4 units here. I'm going to have to label number 1 there. Take care of that in a minute. And we want to move up 4 units here. So this would be number 3. Number 1 would be here. Now, if you haven't done the last, you do it. You need to do these to see whether you're doing them right or not. Okay. Okay, so we move no units in the horizontal direction and 3 units, -3 units in the vertical direction. Means this corner is not going to move horizontally, but it's going to move 3 units downward, which will put it maybe back here. This corner will also move 3 units downward, which will put it here. This corner will move 3 units downward, which will put it about here. This corner 3 units downward, which puts it back in. There would be number 4. Now, let's say that we have a toolkit squaring function in the first rectangle. Then, if the toolkit squaring function is also transformed in each of these ways, we're going to get each of the graphs that I'm going to draw here. And I'm going to kind of draw the graphs in unique color. Kind of missed the corner there, but you get the idea. In this graph, where my axis of symmetry, we would have a graph. Okay. looks something like this. And that would be my number 3. Take every point of this parabola, move it the same as I did. Well, move it according to the rule, over 3 up 5. So from over 3 units up 5. Okay, number 2. Yeah, all up here. Oh, I'm picking up. Okay. Number 2, the graph would go in here. And number 4, graph could go in here. Now, all those graphs should have the same shape. Although this one seems to be somewhat distorted. But they'll have, if this is done accurately, if every point is moved exactly, whatever, horizontally and vertically in the same way, then we're going to get these graphs. Okay, well, there's more we can say about that, but I'll save that for the next video.